Hi there, it's Z here, and this video concludes a series that I've been making on using the tools of linear programming to help optimize capital budgeting. When I first started making these set of videos, I never quite expected to be generating this much content where I had a look and I have almost an hour worth of me walking through the scenarios. But hopefully someone out there finds this useful. Now in this video, I won't be going through any more um, tools and scenarios, but instead I wanted to focus on some of the maybe more philosophical concepts behind problem solving and supporting decisions with models. So in the preceding videos, we've done a whole bunch of scenarios where the assumptions got more and more complex to eventually reach something that hopefully look a bit more like a real life situation. And we had to sort of ramp up our tools from the basic Excel solver to more advanced add-ins and um, eventually using code from Python libraries like PulP and Pyomo. And I think at the very end, we ended up looking at a commercial solution. And it's I think what I did not cover in all these previous videos is maybe taking a step back and talking about the modeling process itself. So I'm going to do that here. Now, a few things that come to mind. I think the first one is to be aware that the map is not the territory. And this is a expression that means if you're building a representation of a problem that you're trying to solve, you need to be aware that the model isn't always going to be a full reflection of the real world. And this is a related expression that is attributed to the statistician. All models are wrong, but some models are useful. So from a perspective of this capital budgeting, I think the examples that I've shown you, even though I've taken more than an hour to crank through the scenarios, linear programming is only one way of doing this portfolio selection. And if you look online, there are a whole bunch of other tools and approaches that you can use as well. It's important when you're doing this that you pick an approach that works best for your stakeholders, which leads me nicely to my point number two. If you're going to build a problem-solving model or something to support a decision, you need to make sure that it's easy to communicate and understand. Part of the danger of doing models is that as the complexity grows and more assumptions are made, exclusions are included, you can end up with a number that's produced or a recommended solution, but you have lost the traceability and understanding why the answer looks the way it is. So it's something to keep in mind when you are developing any sort of model to support decision making. And point number three is really about you have to sort of step back and look at the problem frame itself, because all decisions usually are made within a frame. So there may be a time frame for how long you have until you need to sort of lock in a decision. There may be a something around the quality of the information that you get as input to your model, garbage in, garbage out. And one framework that I quite like is by the Strategic Decision Group, and it's about decision quality. And the whole bit around modeling is only one aspect where it's a decision support tool. But the wider frame is you need to understand what's the decision that you're trying to make, information that you have, and you find that the modeling bit sits really within the understanding the trade-offs and the reasoning behind the trade-offs bit. So um, I think that's the three things that I wanted to share. As far as the tools go, I'm hoping that I've given you a comprehensive overview of uh, all the different toolkits that are available within Excel and also programming solutions that are available. There are, of course, more out there. You could, instead of using Python, use other programming languages, and there are other companies that produce equivalent tools commercially besides Frontline Analytics. But I hopefully have shown you that you can still achieve quite a lot, even with the open source freely available tools, if you're willing to trade off some time to understand how they work, and you're not so fussed about computation time. So I think that brings me to the end of this series. So thanks again if you followed through all the different videos, and see you next time.